They say there are only two hard things in computer science: cache invalidation and naming things. This was said by Phil Carlton, a Netscape engineer back in the 90s, and he was right. Naming is difficult, but it is a key quality of writing readable code. Today we're going to go through some rules of naming and attempt to provide some guidance when naming methods, variables, classes, and assemblies in C#. Let me be the first to say I am no expert in this arena. I have a lot of learning to do. My spelling, and maybe just learning some new words in the dictionary. But I'm going to give it my best shot. If you don't know who I am, my name is Justin Colston. I'm the founder of SparkPoint University. And if you're new here, don't forget to subscribe and like this video. Alright, let's get to naming things. So let's start with two basic casing styles that are most common in C#. The first one is Camel case. Everybody's seen this, and typically I only use them for local variables and parameters. So for example, let's zoom in here. Var local variable name equals string, right? It's just an empty string. The first letter of the first word is lowercase, and then each word after that is capitalized afterwards. This is known as camel case because of the humps in the middle where it starts low, ends low, but it's high in the middle. I got two humps in here just like a camel. Now, the other one, of course, is Pascal case. That's a very common one as well, and typically I use those for methods and class names, file names, and assemblies. That is named after the Pascal language. It became a popular approach to capitalize the first letter of every word. So in this case, I might have a public class, and I might say product, capital P. Maybe it's product entry. So the capital P comes at the beginning, and then every word afterwards is also capitalized. However, within a word, it is lowercase, and that can be true for abbreviations as well. So those are the two basic rules of naming, and you want to be consistent throughout your code base. However, that's not really about naming, that's more about casing. So, whatever your company does as a coding standard, follow that. But ultimately, these are really the two main styles. Occasionally you'll see snake case and some of these other ones, but those are a lot less common in the C# world or even the .NET world. So let's get started with naming. So I think we're going to start with class names because that's something we use all the time. I prefer naming classes as nouns. In the singular form, it's going to be a singular noun of some type. So I use Pascal casing, so we'll do a couple examples. So one, we'll say I'm going to have, like I had before, product. So I have public class product. Maybe I have public class inventory entry. And then maybe I have a handler. Public class create command handler. Now, there's a lot of ways, and maybe I don't even have to have handler on here. I could just have create command. That is still considered a noun. It's create something, but let's be more specific. Create product command. That's still a noun. What I would not typically do, and I don't personally condone this because it can be a little confusing sometimes because we are using classes, I wouldn't necessarily have like a get products class. I've seen this before. It's not wrong. I mean, we're programmers. Like, none of it's necessarily wrong, but it can be kind of hard to read. To me, a class is an object. And when you use object-oriented programming, when you start creating instances of get products, how do you reason about that, right? It's not an object. Is it a command? Is it it's not a query? I mean, what is it? So typically, if you're going to use some kind of form like get products, just, put a suffix on there of get products command of some kind, right? Or maybe it's not a command, maybe it's a query, right? Because we're getting products. So get products query. So the get products is a descriptive of query. So the base noun is going to be query in this case. It could be the base noun could be command, and we should always have that base noun, but then be more specific. So for classes, typically you want to be as specific as possible. So another example might be, let's say I have an interface. I'm going to have an iProduct repository. Now, I will say this is probably one of my biggest pet peeves when it comes to interfaces and classes that implement them, is that I cannot look at something that says, well, they even recommend it. Product repository, iProduct repository. This drives me nuts because it kind of implies that you don't have another implementation. Or what is this implementation? Like, you're just going to have one? Why do the iProduct repository at all? Doesn't make sense to me. So when it comes to naming classes when they are implementing an interface, what I typically do is I'm going to name it based on the technology I'm using. So in this case, let's say I'm using Entity Framework. If I was using Entity Framework to implement this repository, I might name it Entity Framework Product Repository. Now that might seem redundant if all you're using is Entity Framework, but at a larger scale architecture, you typically don't want to put these repositories with your web project or like embed them into your main monolithic app. It's usually better to separate that out into a separate assembly. Why? Because then you can re-implement with another technology. For instance, I've had to do this several times with Entity Framework. A developer may have come along and used Entity Framework, may have been new to it, and there's a lot of poor performance with it. Well, you can fix it up and you can work on it and try to figure out how to make it work and run SQL manually. However, for me, it's a lot simpler just to pull Dapper down, write the SQL real quick that we need, and then create a new implementation of the product repository. So what I would do typically is I would then go in here and I'd say SQL Server product repository, create a second one, and now we have a second one in place. And then I can have both of them still. I don't have to delete this. I might want to do performance or A/B testing on it. There's a lot of things you might want to do from a standpoint of having both. So I would create a new assembly for SQL Server and keep Entity Framework in the previous assembly. And then I can go to the dependency root, which is where we do all of our dependency inversion container, the inversion of control container, and I would just switch them out. So my point is that be specific as possible when naming your classes. There's no reason not to be. It makes it easier for developers, and it makes it easy to find. But of course, there's other things that go into this, right? Namespacing, for instance. How do you find these classes and things like that? Well, typically when I start performing namespacing, what I'm going to do is I'm going to start with my organization. So my model is fairly simple. It's going to be organization dot domain, any number of domain or subdomains within that organization, and then it's going to be the actual purpose, right? Implementation. Okay, so let's create one now. So let's say that I have a data domain, but I want to be specific. So this is my inventory system. So let's call this, say, namespace. Whoops, naming. I'm thinking two different things. Namespace Spark Point University dot quick inventory, right? Let's say it's called quick inventory. So that's my domain. And then it's going to be my data layer, but I kind of want to keep it under products. So that's going to be my product subdomain. Then I'm going to have Entity Framework. Now, to some degree, this is it's a little redundant, right? Do I really need to have this now that I have a domain, a namespace in place? You know to go here, and when you find product repository, it's there. Not really, right? I mean, the reality is you don't have to, but it makes it a lot clearer what this product repository is now, and that's the benefit. No matter what, you know what it is. You don't have to guess. So I would do something very similar here with the SQL Server one. Keep doing that. Spark Point University dot quick inventory dot products dot. Now I could do SQL Server, or I could even be even more specific, say Microsoft SQL Server. And some people might even go Microsoft.SQL Server, right? That seems like it's a little too much. I like to limit it to about 4, maybe 5 namespaces, but that's getting a little far out there. So let's just do SQL Server. Most people, when they hear that, they know exactly what it means. It means Microsoft. Okay, great. And then, of course, at the top here, I have my iProduct repository. And so I'm going to do something very similar. The difference here is it doesn't really have a technology that's been implemented. So I can do one of two ways. I can stop here and put it under my products namespace. I actually don't think that's a bad idea. Why don't we just do that? However, when I actually create my assembly, so maybe we should differentiate what a namespace and an assembly is, right? A namespace is just an organizational structure of your classes and your code base. Whereas an assembly is a grouping of those classifications, right? They're a grouping of classes and different namespaces and all these different things that you may have. So they don't have to be the same. So what I typically do if I have something like this that are more like abstractions, I will actually name my assembly something like Spark Point University. I typically keep it pretty close. Quick inventory. And if this is actually in a separate assembly, I could have products.abstractions. That would be one assembly, and it'd be .dll, right? However, I mean, let's face it, we're not going to create a separate assembly for each and every probably domain model, not always at least. So what I'd probably end up doing in this case is I'd probably just have quick inventory.abstractions. And then the same kind of goes with this below. So instead what I would do here is I'd do something very similar. I'd have Spark Point University quick inventory entity framework. And this assembly would hold all of my entity framework implementations for products, for inventory, for categories, whatever I may have in my system. It's all going to live in this one DLL. Makes it a lot easier to package, makes it a lot easier to download. And then I can go down to my SQL Server one because I want to have 2 different versions. So I'm going to say SQL Server here. So you can see that the assembly does not have to necessarily match up with the namespaces. Now, as I look at this, it almost feels like this is backwards, right? Like I'm looking at it now. Maybe it should be entity framework .products. But you see what happens when I do that? Because this one up here, I have .products for my quick inventory, I kind of lose the benefit of keeping this same sub namespace. So if I'm sitting in this namespace, and all sub namespaces after that will have access to everything inside this namespace. So you notice here that I don't get an underline, right? If I just put anything in between there, all of a sudden it can't find iProduct repository. That kind of stinks. But if I put anything after it, it still works, right? I can go another layer. I can go A.B.C, and it still can find it. So that's why this namespace is a little different from the assembly. And they don't have to be the same. Now, maybe it's best practice in certain areas. Maybe there are rules in your company that you have to do that. So please follow the rules and the standards that your company has presented. But realize that we can be innovative here and we can kind of move things around. And this allows it to be much easier. So I want to say one note on this while we talk about namespaces. When you use namespaces, it doesn't actually matter at all about the assembly. For instance, let's just say we wanted to add a new iService collection extension. Okay, so let's just create a class. We're going to create, and let's go ahead and delete some of these. Okay, we're going to create a public static class, service collection extensions. All right, awesome. And then in here, I'm going to static, and I'm going to say iService collection. And we're going to add our repository. We'll say add product repository, right? Okay, we're going to do this. And we're going to say iService collection services. Okay. One of the benefits of namespacing is that I can actually reuse this. So right now, if I was to delete this, I can't find service collection anymore. Okay, well, that kind of stinks. So why don't we do this first? Let's jump out of here. We're going to move this type. Okay, we're going to move it out into this assembly here. And instead, what I'm going to do is I'm going to create a namespace here. I'm not actually going to create one. I'm actually going to use the iService collection namespace, which I believe, if I'm not mistaken, Microsoft.extensions. Dependency injection. Okay. So I don't own this namespace, right? This namespace is not owned by me, but I can still use it. And then whenever I add this assembly to my project, I will now be able to have add product repository whenever I use this namespace. Very obvious after the fact, but you don't really think about it when you're actually writing your own code. You think namespaces should be something you own, which is actually not the case. The assemblies, yes, but not the namespaces. So let's come back in here, and let's just say I have, let's create another class here. Actually, we don't even need to do that. I'm going to go here, and I'm going to say iService collection services equals null for now. I'm going to use Microsoft dependency injection. Now, you may think, and I guess we probably to, well, it'll probably still work. Let's see. Services dot add product repository, and it shows up. Now we made up the namespace on this, so it's not like it's finding it. No, it's finding it because this is actually in the namespace of iService collection. A lot of times we use NuGet packages, and you have to use using Dapper or using SparkPoint University. Like that's not fun to me. What's nice is that you can actually simply assign it to the namespace, and then when you actually use that namespace, it's going to be there automatically, even if it's in a different assembly. So, wanted to point that out. But let's move on to the core of this discussion, which is really purely about naming. So, going back to naming, we talked about classes, and we talked about assemblies and namespaces. But why don't we talk about functions? So, naming functions. So, let's create another class here. We're going to say class product. And you know what? I'm going to name this product collection. So still a noun, but I like to have collection, array, list, whatever we need to. Collection is my favorite word to use for anything that's multiples, right? I don't usually say products is not a class name for me. I would normally do product collection, singular as much as possible. But let's talk about functions. There's two purposes to functions. One purpose is to perform some work, okay? The other function is to query. Well, let's talk about one at a time here. So commands. Let's talk about performing work, also known as a command in CQRS. So when you do a command, typically you want to have a verb and a verb modifier when you're naming, or a predicate, right? You're thinking a predicate. So I have this product collection, and I want to add, say I want to add an entry, right? So I would say something like add entry. And maybe I pass in product here, which I don't, of course, have. We'll let it create one for me real quick. All right, so we have product. And you see here that it's add and the predicate for add. But if you read this in a sentence, you're basically saying that I want to add an entry to product collection, right? Or the product collection is going to add an entry. So the product collection is the subject of the sentence, whereas add entry is the verb and the verb modifier, which is called the predicate in English. That's what we're aiming for when we actually write methods out or queries, right? It's the predicate of a sentence. Now you have to modify it a little bit because it doesn't perfectly make sense. It's not like I'm putting the product collection is going to add an entry, right? No, I'm not doing that, but that's really what we're aiming for is add entry. Or add an entry, right? You could do this as well. It's a little more verbose, unnecessary. So I will typically remove some unnecessary prepositions and things like that as I can. So add entry. Another example might be public void delete entry. I might pass in product again. Okay. Well, that's the command scenario. Command scenarios are pretty straightforward, right? You're really going to use action verbs: create, write, build, perform, delete, handle. Actions that push. So when you're talking about commands, you're talking about outward actions, right? So I'm going to create this, I'm going to write this, I'm going to do something away from me, right? That's how I like to name functions that are commands. But then you have the other type, which is queries. So that's more about retrieving information. That's about pulling information. So same thing, it's still a predicate, it's still a verb and a verb modifier, but you use a different set of verbs. And again, actions that pull. So maybe it's like get or load or pull or read. So if I want to get a bunch of products, it may be product collection. Maybe we'll just do this again and we'll say, well, that's not going to work because product, say an array, get entries, right? That's a query command. So I use the rule of push and pull when I'm naming functions, right? And it's going to be based on the actual class I'm sitting in. So we don't want to add functions or name them funny where it really doesn't belong in that class. That's where the single responsibility principle comes in. So I'm not going to have, typically, I'm not going to have a function here that might be to modify an entry. So I'm not going to do something like void set product name product and then string name. Like, I'm not going to typically do this, right? This doesn't necessarily make sense to be a part of the product collection. So the product collection is going to set the product name. Well, I mean, I guess if it makes sense in your application, sure, but to me, this can go somewhere else, right? So you want to keep it within the scope. So your noun in your sentence is going to be product collection. However, you then have your predicate is going to be each function. So add entry, delete entry, get entries, whatever it may be. So that is how I work on naming functions. And again, this is Pascal casing. So you start with a capital letter in each word. But I've been showing you public functions. This is true for all functions for me. It doesn't matter if it's private, internal, static, it's always the same. So even if I do a private void initialize, right? I'm going to have an initialize collection. Okay, so my product collection is going to initialize the collection. So, okay, it's still Pascal case. Some folks like the Camel case in this when we're working through like private aspects, but I think it's actually easier for me to understand that it's a function or a property when it's Pascal case. And then local variables I always know are Camel case or stuff that's within my class, like fields or private fields, things like that. Okay, so now that we have some functions, why don't we talk about parameters, properties, and some of these other aspects of a class? So first thing, let's talk about a property. A property to me is basically functions, just getters and setters, right? We look at them as more objects a lot of times. So because there's already a get and a set that's a part of it, I typically like to name my properties around a noun or an aspect of the class. So in this case, we talk about simple properties like length, right? That's a simple property you've seen probably 100 times, or count. So the product collection length, or the product collection count, or the product collection rank, right? These are the type of things that I would name it. So it's basically a property is a property of the object. I mean, that's why they named them properties. So the way I would typically go about this is just that make sure that it continues to be a noun, but a noun that's relevant to the product collection itself. Again, Pascal case, nothing special there. So when it comes to private fields or read-only fields, because you're injecting something, I basically just use Camel case, but I prefer an underscore in front to signify it's a field at the class level. This is more of a preferential thing, but Camel case. And again, I use the object or the property method. So just like length, I may have a private field of length that might be length. Now I've seen it done both ways. Sometimes it's nice to match them up. So sometimes I've done this in the past where I'll use Pascal casing for it. Again, we're talking about naming, so it's not as important here, but you can underscore capital L, underscore lowercase l. Don't know that it matters a whole lot. I prefer to match it, especially if it's a backing field, because then I know underscore length is the backing field and then length and their exact matches. The only thing that's different is that underscore. So typically if I have something I'm injecting, like a I don't know, a data serializer maybe. So let's say I have product collection and I'm passing a, why not? Serializer, because maybe I need to do some serialization in this class, which is probably unlikely, but that's okay. Let's generate an iData serializer, and then I might actually name this private read-only serializer equals serializer. That's not how that works. Silly Justin. And of course I gotta actually have my type. I guess I make mistakes a lot more often. Thank goodness that Visual Studio tells us everything is wrong. Otherwise, I would be a terrible developer. Who knows? So, in this case, I have an underscore serializer. Again, it's a noun. And now we're kind of getting into the parameters aspect of this. So, parameters and fields, they are different, right? So, a field is almost like a scoped variable for the class, whereas a parameter is only scoped to the function. Most of our code that we're going to write typically is going to live in a function somewhere. So we want to kind of differentiate those and know when something is actually shared amongst functions versus something that is actually just a part of that one function. So let's kind of get into parameters and variables directly. So here I have add entry, right? We've already talked about add entry. And you notice that it's camel case product, and it's also an object. Sometimes, though, it's recommended that instead of just having a kind of a bland, like here it says product, instead of having a bland name, there may be cases where you want to pass in two products, like a comparison algorithm, or maybe you have a very specific algorithm. Maybe that's what we should do. Let's delete this product collection, and we're going to have a very specific class, and it's going to be a pizza parlor algorithm. And we're going to run this algorithm against two different products, right? So we're going to have public void run, and we're going to have product number one is going to be our pizza product, and product number two is going to be our topping product. And we got rid of our collection, but we could have a collection as well and put it in here. So I named it specific. Even though I have two products coming in now, I don't want to just name each one product one, product two, which is very common. I've seen that before. You might have product left. I've seen this before. Left product and right product. Not helpful. I don't know what this means. Unless as you're doing operators, like you're extending an operator or static operators, this doesn't mean a whole lot. Like left operand and right operand actually makes sense when you're doing operator implementations, but for a very specific function that you're creating that's about running an algorithm, these don't make sense. So be specific. In this case, we'll switch it back to pizza product and topping product. Okay. So, and then we want to combine these products. Actually, I should change it around. Let's say crust product. Let's do crust product here. I want to turn both of these into a pizza product. Right? I'm going to take a crust product and a topping product, and I'm going to turn it into a pizza product. So that's where the variables come in. So variable naming, again, just as important. So I'm going to call this pizza product. And I'm going to say it's just equal to new product because I don't have any real logic in here. And then I can do my work, right? So this will be all my logic for combining it. Great. I mean, this is awesome. But somewhere I have a for loop. Maybe I'm for looping some parameter on my product. So I may have a for loop here. Now I'm going to name my variable inside here. I'm going to say I is less than, I don't know, 5, I plus plus. So let's talk about this type of variable. So local variables, again, be as specific as possible. Use camel casing because it distinguishes the variable from field level variables. Because if I had a field in here, like maybe I have a sauce field for some reason. Let's do that real quick. I might have a product sauce field or sauce product. Right? I can then use that down here. I may want to use, sauce product. But at least here, when you see the underscore, you know that it's at the field level and that it's a shared product. And we should probably not modify it unless we have good reason to. But we do know that anything that's lowercase or camel case in here, we have full reign to do what we want in the method. But then we get to the for loop, and now I have just an I here. This is one of the few exceptions to not naming something more specific. I and J are pretty much standard index operators, or variables, sorry. I traditionally means index of an x coordinate, and J usually is that index of the y coordinate. And I think it comes from typically like the mathematics when they were doing complex numbers, right? You have I and J, I think is where it comes from. I'm not going to swear to that. But these are like some of the few examples. Now, if we have something more complicated, like we know this is an index of a very specific property, we have multiple indexes, I a lot of times will do I index of maybe I product, right? Knowing this, that way it says it's the index of the product. But you could easily just as well just say product index. And this is more readable from a standpoint of knowing what's going on. So again, a noun, you should always default to using the noun and trying to write everything else instead of using abbreviations. I is an abbreviation as far as I'm concerned. I think because it's so close, the closer you are to the function that's using it, or the for loop or anything like that, the more acceptable it is to have shorter names, maybe even some names that are not quite as understandable. But I will say that developers will thank you when you spell it out. So spelling out product index is probably going to be a better decision than using I everywhere. And nesting, if you have multiple nested, like 3 or 4 nested for loops, first of all, probably a bad algorithm, so try to fix that. But otherwise, having I, J, K, and L in there, and then trying to keep those things matched up inside the for loop is kind of difficult. So I recommend that unless the exception is I, J, X, or Y, or it's a mathematical symbol like a domain object for a mathematical symbol like E, or PI for pi, right? I recommend writing these things out. Keep your variables as close to where they're being used as possible. There's no reason to put them all at the top of the method and then try to figure out what's declared up there and what's not declared up there. So if I don't use product index until down here, declare it down here. If I don't create the pizza product until after the for loop, then let's just declare it down here where we actually use it, right? Maybe we do for loop first. Let's declare it down here. Not everything has to be at the top and not everything has to be at the bottom. So last thing I want to mention, and I'm going to use a very basic use case, is abbreviations. So abbreviations really should just be avoided. I can't think of a lot of good reasons to ever use abbreviations. But if you do use an abbreviation and it's 3 letters or more, capitalize only the first letter. Okay? Maybe an example is DAO, right? So I think it's data access object. You'll see sometimes you'll have like a product DAO. Well, just name it DAO like this instead of all caps. Might seem counterintuitive, but it's pretty much a standard in the industry these days not to have a bunch of capital letters throughout name classes. Instead, we know this is a product data access object. The only exceptions I can think of that I may perform is things that are super obvious. And it may be something like, I don't know, states. Maybe you're coming up with a map, and so you might have a region, and then maybe you inherit from that region. Maybe you have public class region SC for South Carolina, right? And then maybe you have a public class, region for Indiana. And even then, I don't think that I like this. I'd almost rather just have it named Indiana. Like, this is even clearer. So, yeah, no, I think that's one of the few exceptions I've seen in the past, but really just spell out the state name. There's no reason to have an abbreviation here. That way you know exactly what it is. SC can mean a lot of things, so why don't we just spell it out as South Carolina? So this pretty much concludes our video. For the most part, naming can be somewhat simple. Really the goal is to be specific and to make it very useful for the developer that comes up behind you. So use nouns for classes and objects and properties, and use predicates for functions like the commands and the queries. Hope you liked this video. Please don't forget to subscribe and like this video, and I will see you next time.